Recap. A isosceles triangle has at least two congruent sides. Those two congruent sides are called legs. An isosceles triangle has at least two congruent angles. The angles are called, the congruent angles are called base angles. The base angles are opposite of the legs. And the angle between the legs is called the vertex angle. So let's kind of play with this for a second. Maybe erase all this. And let's look at some questions you might see. Do you have the ability to solve for x? Yes. What is x?
40.
X equals 40, and why does x equal 40? Because base angles are congruent. That makes sense? So there's not really a lot of math that goes on there. Base angles are congruent, so this is 40 degrees. Now do you have the ability to solve for y?
Yes.
Okay, how many degrees are inside of a triangle?
180.
180 degrees. You already have 40 plus 40, which is 80, which means how much is left over for the vertex angle? 100 degrees. Does that kind of make sense?
Yes.
So in this scenario, because it's an isosceles triangle, we only really need one angle. So let's go with the hard version. The vertex angle is 80 degrees. How big is each base angle? How did you get that?
Because there's 180 in a triangle, and subtract 80, there's 100.
Now, why are you dividing by 2?
Because there's two angles.
So sometimes it's nice to see that base angles are equal, and you could say 80 plus x equals 180. The equation, if you combine like terms, you get 2x, subtract 80 from both sides. That's why you're dividing by 2, because 2x equals 100. Let's try a harder one yet. AB is congruent to AC. Why? Base angles theorem. If you have two congruent base angles, you can justify that this piece and this piece are congruent. The reasoning, like in a proof, would be the base angles theorem. Alright? What about, let's go for a really complicated one. Y'all ready? X is 5. And then here's a test question that we give in the regular class. This is a good one. What?
3x is equal to 2x plus t, which means the 2 has to be x.
So the main part that starts this problem is which two expressions are equal to each other.
3x and 2x plus t.
These two expressions are equal to each other because they are describing the congruent legs of the isosceles triangle. So 3x is equal to 2x plus 2. If you subtract 2 x's from both sides, x equals 2. Most people say that the answer is 6. Why? Why would someone say 6? Because 3 times 2 is... So they're giving the answer for a length on accident. But what is the question really asking for?
It's the space.
The base, right? The base. So what is 2 plus 3? 5. That's why the question is so complicated. All right, let's get to the next one. What do you call this triangle? Like what?
Equilateral.
Okay, so this is an equilateral triangle. What is an equilateral triangle?
A triangle with at least 3 congruent sides.
So if you say at least 3 congruent sides, could it have 4 congruent sides? So an equilateral triangle has 3 congruent sides. Period. There is no fancy way to say that. 3 congruent sides. There is nothing else to say about equilateral triangles. They have 3 congruent sides. They're basic. And how else would we describe that triangle? Okay, that's the definition. But what is the name of a triangle with 3 congruent angles? No, equilateral. Equilateral is 3 equal lateral sides. Equiangular. An equiangular triangle is a triangle with 3 equal angles, or 3 congruent angles. That might be very nitpicky for some of you guys, right? Why does that triangle have 2 different names?
Because an equiangular one could be different. Because it got bigger sides.
My question is, are all equiangular triangles also equilateral?
No. Yes.
Because all equilateral triangles are
All equilateral triangles are equiangular, and all equiangular triangles are equilateral. Does it kind of make sense?
Yeah.
But if it's like an equiangular triangle, can its sides be different?
Yes. So, here's where you're stuck. You want to talk about an equiangular triangle, right? Then you say the sides are 5, 5, and 5. Is that true? Is this equiangular? Is it equilateral?
Yes.
But when I say like 7, 7, and 7, is this equiangular? Is it equilateral? But are these 2 congruent? No, I don't care about that. I just want you guys to solidify the definition or the description of equilateral and equiangular. Okay? Now, what else can we say about equilateral triangles and equiangular triangles? Is there anything else to say?
The height.
The bases and the matrix are
Can you name a
Yeah,
base and a
that's
vertex?
good. So, the degree measure of every equilateral and equiangular triangle is 60. So every equilateral triangle has angles that measure 60 degrees. Every equiangular triangle has angles that measure 60 degrees. And that's it. Is it?
I feel like it's boring,
Do you?
but I feel like you can make it really confusing.
I'm still waiting on one more description. So reach in your little pretty brains. How else can you describe that triangle? This triangle is equilateral. This triangle is equiangular. This triangle is
Equal to what? Symmetrical. Wait, no.
What? Isosceles.
Because it has at least.
Is this an isosceles triangle?
Yes.
Does it have two congruent sides?
Yes.
Does it have two congruent base angles?
Yes.
It is an isosceles triangle. Hold on now. So every equilateral triangle is an isosceles triangle, but not every isosceles triangle is an equilateral triangle. Ooh. We play that always, sometimes, never. Do you want to get to that game?
Not right now. Not yet.
So, you ready? A square is always a rectangle,
But a rectangle.
but a rectangle is not always a square. A square is always a rhombus, but a rhombus is not always a square. A rectangle is a rhombus when it's a square. Holy, you opened the box and I just regurgitated information. Okay.
Don't go there.
Don't go there. So I think that's about as much as I can get into with these shapes. Now it's just, can you apply the information? I don't see you guys needing to write a lot of this down. I think you can.
Are they isosceles or is it like?
So equilateral triangles are isosceles triangles, but isosceles triangles are not equilateral triangles. I don't see you guys needing to write a lot of this information down. It's going to be more of like a see and speak type deal. So we go through some basic representations. It says, do you have the ability to solve for the measure of angle A? So you must first identify what type of triangle angle A is contained in. How do you know it's an isosceles triangle?
Because it has two base angles.
It has two congruent base angles. So in this triangle right here,
Wouldn't you say equal because that's gonna
those two angles are congruent, which means they are also equal. What is the measure of angle A? If you take 180 degrees and you subtract the vertex angle of 40 degrees, you're left with 140 degrees. You must split that equally amongst the two base angles, and you get how many degrees for each base angle? 70. Does that seem hard? Right, besides me verbally speaking it. Ooh. How long is FC? FC is this line segment right here.
Are there any measures for the? Oh, 4 units. So there's 2 right there and 2 right there on the.
Did you see that FC is contained in this equilateral triangle? Or sorry, that equiangular triangle. And because that triangle is equiangular, it is also
Equilateral.
equilateral. And then the hidden measurements of 2 plus 2 equals 4. So FC is 4 units long. That's so now it's about seeing the information and how it's presented. What is the measure of angle X?
60.
Why is angle X 60 degrees?
Because it's equal.
Because it is an equiangular triangle, and by definition, each angle in an equiangular triangle is 60 degrees. Ready? How big is angle Y? Angle Y is contained in this little baby triangle right here. What? You're correct. How? So fast.
Because angle A and angle E have to be the same.
So we calculated angle A was 70. So if angle A is 70,
Angle E is 7.
perfect. Great.
And then because.
And then G is 60 degrees because angular triangle. So that means that C has to be 60 degrees. And so the 130 minus 180 is 60.
So we have 60, 70, and angle Y. There should be 180 degrees in that triangle, and 180 minus 130 is 50 degrees. Perfect. You guys need help with this too. So this is not a number question. This is a geometric practice naming angles. Because some of you guys are really good at that. right? No. It says angle EAB is congruent to which other angle? EAB is this angle right here.
The hard part is finding the letters.
Yeah. Well, you haven't even seen your test yet, have you? And he said angle EBA. Correct. Angle EBA. And can you justify why those two are congruent? Base angles. Base angle theorem. Right, and you can say the isosceles triangle theorem if you'd like. Base angles theorem. Alright, what about angle BCD, angle something, and angle DBC are congruent? BDC. So we got angle BCD, that's this angle right here. We have angle DBC, that's this angle right here. And they are all congruent to which angle? BDC, and you have to justify why those are congruent.
Because equilateral triangles are equal.
Oh, I'm sorry, were you making fun of me earlier?
Equiangular triangles. It's such a weird word.
Sweet, right? Because equilateral triangles are also equiangular triangles, and equiangular triangles are all congruent. So BBC. FG is congruent to what? Which is also congruent to DF.
GD.
GD. It's line segment. GD.
Would this be relevant? But BDC and then FDG, would that be congruent because of vertical angles? Or would it just be?
You could say that. That's a good thing to justify that these two angles are congruent.
You could also just nullify.
And then that would be congruent to DFG.
And that would help you get into this triangle over here, so you could say that all 6 of those angles are congruent. And using vertical angles to transition into the next triangle.
And then angle GDC is congruent.
Alright, so let's try a little bit of math here. Let's do the same thing with some numbers. It says, how big is angle ACB?
This is the hard part, is trying to find the letter. 60.
Why is angle ACB 60 degrees?
Because an equilateral triangle is equiangular.
Because all equilateral triangles are equiangular triangles, and the measure of each angle in an equiangular triangle is 60 degrees. How big is angle DCE?
65. I think. Yes,
I need you to know for a fact.
65. 65 degrees.
180 minus the vertex angle is 130. That means there is 130 degrees to split equally amongst the two congruent base angles. 65. And how big is angle DCB? How do you know that? There is 180 degrees across every line in geometry. So 60 plus x plus 65 should equal 180 degrees. So when you solve for that, you get 55 degrees. Let's look to your homework real quick. Let's go to the last question. Wouldn't be geometry without some proofs. Alright, we have 10 minutes, so let's be efficient. Angle BAC and angle BCA are congruent. So BAC, that's this angle right here, and angle BCA are congruent. Why are those two angles congruent? Side BD is
Side BD is congruent.
so hold on. It says the converse of the base angles theorem.
Oh, we should fill in for the.
Yeah, let's go ahead and do that. That's where I was going. What else is given?
Side BD is congruent to side BD.
I'm going to do this a little different, and hopefully you'll see why here later. BD is congruent to BE. Now it says number 2 blank, the converse of the base angles theorem. So this was me saying if base angles are congruent, then, or if sides are congruent, then base angles are congruent.
Sides.
So if base angles are congruent, you can conclude that
Sides.
sides are congruent. So we
Side
have,
BA is congruent to BC.
yes, we're trying to say that this side is congruent to this side because of the converse of the base angles theorem. That is, side BA is congruent to side BC. And then angle B is congruent to angle B. The reflexive property. Is that?
Well, how do you, what would you say it congruent?
Well, it says we're using the side angle side shortcut.
BAC is equilateral triangle.
What?
Or not equilateral, is a.
So we're using the side angle side shortcut. So let me draw that for you. We have this green side is congruent to this green side. Right? Then we have this red side is congruent to this red side. Then we have these congruent angles between them. So I'm really drawing red angle or green angle red. That is
Triangle,
this triangle right here.
triangle DCB is congruent. Triangle BEA.
Do you see that those two triangles are congruent?
Yes.
That is tough to see, isn't it? That's the side angle side shortcut. That is triangle B. What'd you say? What'd you call it?
BCD.
BCD is the blue triangle.
BE, or yeah,
So-
BA.
BCD looks like this. And that's going to be triangle BEA.
Well, no, it'd be BA.
Yes. Triangle Bay. There she is, my whole life we're looking for. And then finally, angle BDC, angle BDC, that's this angle right here, is congruent to triangle, or angle BEA. Why are those two angles congruent?
CPCTC.
Because corresponding parts of congruent triangles are congruent. Guys, that's nasty, isn't it? Why, look, why is that so bad? Because that's called overlapping triangles. And that's what our concept is on Wednesday, is overlapping triangles. So you'll see triangles that look like this. So that's going to be tough. That is homework. So everything else beyond that should be pretty quick and not super crazy. I'd like for you guys to work on that one.
There's nothing beyond that. It's the last question.
Right, but everything before that.